In this precalculus algebra video, we're going to talk about solving what are called nonlinear systems using two methods. First, the substitution method, and then what's called the elimination method. And a couple of points to note, first of all, that we use the substitution method when we have multiple equations with the same variables, and the elimination method we use under a stricter condition. That is, not only do we have the same variables, but one of those variables is raised to the same exponent, as we're going to see. So let's go ahead and take a couple of examples. First, we'll start off with the substitution method. So let's use substitution to solve. And the first thing we want to note is that this is a nonlinear system. And by that, the reason it's nonlinear is because even though the bottom equation is a linear equation, the top equation isn't. And that makes the whole system nonlinear. So we're asked to use substitution to solve. Now, we actually could not use elimination in this case because even though these are the same variables, we don't have a situation where the variables are raised to the same exponent. So we'd actually have to use substitution in this case. So let's go ahead and solve for one of the variables. Why don't we solve for y in the second equation? Now, the reason I'm choosing that is because it's easiest to solve this bottom equation for one of the variables, and y is easiest because it doesn't have a coefficient, or only has a coefficient of 1, I should say. So solving y in that second equation, we end up getting y is equal to, it's going to be 3x take away 10. So I just brought the negative y over here, and then I subtracted 10 from both sides. And now I want to substitute that expression for y into y in the top equation, like you've done before. So we take x squared plus y squared is equal to 100. And we're going to replace y with 3x minus 10. So x squared plus 3x minus 10, quantity squared, equals 100. So expanding this out, x squared plus 9x squared minus 60x plus 100 is equal to 100. So we've got x squared plus 9x squared minus 60x. And then subtracting 100 from both sides, we get 0 on the right-hand side. Combining like terms, 10x squared minus 60x is equal to 0. So factoring out a 10x, we have 10x times x minus 6 is equal to 0, and we get, setting each of these equal to 0, x is equal to 0, and x is equal to 6. Now, these are restrictions on the x-coordinate. You have to plug each one of these in to find the corresponding y-coordinate. So we're going to have 2 points of intersection. So when x is 0, y is 3x minus 10. So y is going to be 3 times 0 minus 10. So y is going to be negative 10, and that yields the point 0, negative 10 as 1 point of intersection. By the way, when you solve a system, you're finding a point of intersection of those two curves, as we'll see in a moment. And when x is 6, we have y is 3x minus 10, so y is equal to 3 times 6 minus 10. So y is equal to 18 minus 10, so y would be 8, yielding the point 6, 8. So the x-coordinate is inherited from whichever part you're working with. So you have 2 points, right? 0, negative 10, and 6, 8. Now these theoretically are the places where these two curves intersect. Let's go ahead and take a look at that now. So here I've graphed the two curves. The first one was x squared plus y squared is 100, and the second one was 3x minus y is equal to 10. And I can see that the first curve was this circle in red, and the second curve was this blue line here. And I can see that those two curves intersect at exactly the points we found, right? 6, 8 is 1 point of intersection, and 0, negative 10 was the next point of intersection. So knowing ahead of time that, hey, this was a circle and this was a line, it allows you to think about the possibilities for intersection, right? You could have no point of intersection. We could have a line that never crosses the circle, or we could have 1 point of intersection, right, where it just is tangent at only 1 point, or the option that we have here is that the line crosses the circle in 2 points. Okay, let's take another example involving elimination. So let's use elimination to find the points of intersection, and let's write that system down. The system we're going to solve is going to be 3x squared plus 2y is equal to 26. And the second equation is going to be 5x squared plus 7y is equal to 3. Okay, so if you look ahead and you think about what types of curves these are, Notice that the y is raised to the first power, and in both cases x is squared. So these are both parabolas opening. They're both going to be opening down. And so the question is, do those parabolas intersect? Now, first of all, notice that it is a nonlinear system because these are not lines. So if we use elimination is appropriate here because we have variables raised to the same power. So here I have x raised to the same power. So it's easiest, if I can get rid of x squared, I'm sitting pretty, right? So that's what I'm going to do, is I'm going to eliminate x squared. And so what I'm going to do is I'm going to multiply the top equation by -5 and the bottom equation by +3, so that when I add these two together, right, adding the left-hand sides and the right-hand sides together, the x squareds are going to be eliminated. And that's why we call it the elimination method. So we'll take 3x squared plus 2y is equal to 26, and we'll multiply both sides of that by -5. And then we're going to take the bottom equation, 5x squared plus 7y is equal to 3, and we'll multiply both sides of that by +3. Just like you've done before when you're using the elimination method with lines. So multiplying through, you get -15x squared minus 10y is equal to -130. And the bottom equation is going to be 15x squared plus 21y is equal to 9. Then we're going to add those together, and we get, let's see, it's going to be 11y is equal to -121. So I see that y is equal to -11. Now, I've got to go back and find my x, right? So I'll take that top equation, 3x squared plus 2y is equal to 26, and I'm going to replace the y with -11. So I've got 3x squared plus 2 times -11 equals 26. So I've got 3x squared minus 22 is 26. So we're looking at 3x squared is equal to 48. So x squared is equal to 16, meaning that x is positive or -4. Now, both of those values of x are correlated or go with this value of y. So one solution would be the point +4, -11. The second solution is going to be -4, same value of y, -11. So these would be our 2 points. And let's go and see if we can verify that these are the points of intersection of those two curves. So here I've once again graphed both curves. So the first curve was 3x squared plus 2y is 26, and the second curve, 5x squared plus 7y is equal to 3. And notice that they're both parabolas, right? I have the red parabola and then the blue parabola, and they intersect at the points that we found. +4, -11, -4, -11. So we solved this system, that is, we found the points of intersection using elimination. Now you're going to be using this in Calculus 1 because you could be asked the question, oh, find the area between these two curves. So what you'd have to do is you'd have to find these 2 points of intersection, and you'd use those 2 points of intersection as what we call limits of integration. They basically provide a left limit and a right limit for when you're finding this area between those two curves. So this is going to provide a left border, and this will provide a right border for techniques you'll learn about in calculus. And by the way, I should mention that we're using a program called Desmos, which is a free online graphing calculator to graph these curves to illustrate geometrically solutions to nonlinear systems. Okay, until next time.